Hello students. So this is a small Python program to display prime numbers within a range. So low number, high number, these are two variables used to store the lower range and upper range respectively. So we can input the lower limit here. So that number will store in low num. And you can input the upper limit, and that upper limit will store inside high num variable. So these are some prompt message: enter the lower limit and enter the higher upper limit. Then here nested for loop is used for number in range from that lower number. For example, if I need to find the lower range from uh, the prime numbers from 50 to 100. So at first what 50 is the low number, 50 comma 100 is the high number. So 100 plus 1, 101. So 50 comma 101 means in Python low number starts from 50, then 51, 52 up to 100. So we need to add plus 1 always in Python for loop. So 50 comma 100 plus 1 means 50 comma 101 means it starts from 50, then 51, 52, it goes like this up to 100. So number change at first it is 50, then number changes to 51 for each and every number up to 101. For each and every number, what it checks whether it is prime or not. So this is the code for that, to check whether it's prime or not. So flag is set to 0. Flag 0 means when flag equal to 0, we need to consider, this program will consider what it's a prime number. For number 2 in range, so there's another number. It starts from 2 till half of that number. So our number is here, it is 50. First number is 50 here, the lower range. So 50, this is integer division slash slash. So do not return the decimal part, only the integer. For example, 50 divided by 2 is 25. 51 divided by 2 is what? 51 divided by 2. 51 divided by 2 is 25.5. So here the answer is 25, not 25.5 if it is integer division. Okay, that's the difference between single slash and double slash. The single slash means it is the real number division, so it will return the decimal. But here double slash means it returns the quotient only. Okay, quotient. So here 50 double slash 25. 25 plus 1 is 26. So from 2 to 26 means 2 to 25. So it checks, it divides that number. So that's first number is 50. 50, this is modulus operator, means it returns the remainder after division. So when we divide a number, that number 50 divided by, what's the first number here? 2. 2. 50 divided by 2 is, remainder is 0 because 50 is an even number, and also 50 we can divide by 2. Okay, perfectly divisible by 2. So it returns a 0, remainder is 0 there. So 0 is the remainder here. So percent means remainder operator. So it returns the remainder. Here, this is comparison operator, double equal to. So here, what the remainder is 0. So flag is changed to 1 from 0. It's changed to 1. Break means we do not want to check for 50 because the program confirmed that it's not a prime number. So break means we can exit from this for loop. So it goes to the next number. That is 51 here. So 51 flag is again set to 0. Then it starts from 22 to number 2, begins from 2 to what? Half of 51. So it checks whether it is perfectly divisible by that number. If it is perfectly divisible, then it will return 0 after modulus operator. Our modulus means remainder will be 0. Then flag is set to 1. But if it is not 0, if it is not 0, yeah, then we can say that number is a prime number. So it will print if flag equal to 0 and number greater than 1. So number should be greater than 1 also, yeah. Then it will print Yeah, it's a prime number, so it will print that number. Then what's the meaning of this n equal to? So it will print the result in one line. After so we can see space in between each and every number instead of line by line. That's the meaning of. That's the use of this n equal to this. Okay. So for example, I'll explain one number. For example, uh, a small number 13 1 3. 13 is a prime number. So if 13, how it checks, flag is set to 0. Number 2 starts from 2 comma 13 divided by 2 means 6.6 in integer division. 6 plus 1 7. So from 2 to 7 means 2 to 6 it checks. So at first 13 modulus 2. 13 is not divisible by 2, perfectly divisible by 2. Yeah, it's not 0. Okay. Then what happened again? It checks with 3. So from 2 to 6. Okay. So 13 modulus 3. So 13 is divided by 3. So and checks whether the remainder is 0 or not. It's not 0. Okay. Then next number 4. 13 divided by 4 and it returns the remainder. So this is a remainder operator. So 13 divided by 4, no, it's not perfectly divisible by 4. 13, okay. 13 is not perfectly divisible by 4. So it's not 0. Then 5, no. 6, no. So what happened? It's all are not 0. It's not perfectly divisible. So what happened? It exits from this for loop. Finished. Okay. Then comes here. Then check whether flag 0. Yeah, flag is 0. And that 13 is greater than 1. Yes. So it prints that number 13. Then what happened if it is 15? For example. So 15, if the number is 15, flag is into 0. Then it starts from 2. Okay, number 2 is another number 2 for division. If 15 modulus 2, yeah, it's not 0 because 15 is not divisible by 2. Then next number 3. 15 modulus 3, yeah, 15 is perfectly divisible by 3 because the remainder is 0. 3 times 5 is 15 and remainder is 0. So it's 0, yes, right. So what happened? Flag 0 change from 0 to 1. 1 is set to flag. Then break. Why? Because if flag is 1, we can program can confirm what it's not a prime number. So we need not want to check for 4, 5, etc. Okay, so we can stop. This program can stop. Then so we can the program can confirm 15 is not a prime number. Then 16 is also like that. Yeah, it's not a prime number because 16 modulus 2. Yeah, it's 0 because 16 is perfectly divisible by 2. Then what about 17? 17 is a prime number. So how the program can check that? Number 2 starts from 2. Okay. So 17 modulus 2 from 2 to what? 17 divided by 2 is 8.5 means it's 8 here. 8 plus 1 9. So 2 to 8 it checks. So what happens? 17 modulus 2. No, it's not 0. 17 modulus 3. No. 17 modulus 4. No, it's not perfectly divisible. 17 modulus 5. No. 17 modulus 6. It's not. 17 modulus 7. It's not. 17 modulus 8. No, it's not perfectly divisible. So it stops. Yeah. So it exits from this for loop. So the flag is 0 there. No change. So now if flag 0, yes. And that 17 is greater than 1. So it prints 17. So like this, the system program can find about the number is prime or not. So here we can input a range, low number and high number. So between these low number and high number, it can check for each and every number. It can check, the program can check whether it is prime or not. Then if it is prime, that means after checking, if flag is 0 and if number is greater than 1, then it prints. Okay, otherwise it will not print that number. So this break is used to exit from this for loop, this inner for loop. If it is not a prime number, then no need to check for further checking. So it can break. So it will increase the efficiency of the program. So we can run this program. Okay, one module. So lower limit if it is 50 and 100. So yes, 53 is a prime, 59, 61. These are all the prime numbers up to 97 only. 98, 99 are not prime. Okay. Okay, so these are the prime numbers. So we can check for some bigger number one module for 5,000 to 10,000. Look, lots of numbers are there. So these are all prime numbers between 5,000 and 10,000. So we can see gap in between these numbers because we use ND equal to, then we put some space in between. Yeah, that's why. Here each number is separated by space. Okay. So it's our 9973. 9,973 is the last number, prime number, which is just below, just less than 110,000. Okay, fine. So these are the different prime numbers between 5,000 and 10,000. Okay, thank you.